Okay, Honors Algebra 2, we are going to do lesson 4.5 now. So we are on page 9 in your notes, and this is called Factoring Polynomials. Let's start off with the factor theorem. So the factor theorem says, for any polynomial p of x, x minus a is a factor of p of x if and only if p of a equals 0. So what that means, this is a pretty important theorem, and what it means is if you do, if you do long division or synthetic division, and the remainder is 0, then what you are dividing in is a factor. I mean, that makes sense. Like if I do long division into 15, I get 3. The remainder is 0, correct? So that means 5 is a factor of 15. So that's all we're saying here, is that if you divide a polynomial by x minus a, it is a factor if, when you do the division, you get that 0. Okay? So anyhow, I need to finish my little sentence. And the remainder is 0, then x minus a is a factor. Exclamation point. Okay, so let's use this a little bit. Example 1, determine whether the given binomial is a factor of the polynomial p of x. So what I'm trying to do here, I have two ways I could do this. I could say, all right, well, what is p of, like, remember, if x plus 2 is a factor, then x equals negative 2 is the 0. So I could say, well, that means p of 2 is 0. I could prove that. Put negative 2 in there and get 0. Or remember our synthetic division where we write our coefficients for negative 2, 5. Do our long division, put negative 2 here, 4, negative 8, negative 10. And then I multiply again, I get 20, 25. That's my remainder. It does not equal 0. So x plus 2 is not a factor. And if you would have put negative 2 into this function, you would have gotten 25, not 0, and you would come with the same solution. Okay, so let's do this next one again. Or for b, we have p of x equals a bit of a more complicated polynomial, so therefore substituting in negative 2, like we would do here, this would be easy to substitute negative 2 in. This would be a little more complicated. And so we definitely want to use synthetic division here. We're going to do 3, negative 6, positive 6, 3, negative 30. Here is what we want to divide in, but we need to find the 0 for that. So we're going to go over here and set it equal to 0. So 3x equals 6 and x equals 2. That's the number we're going to put in. And we draw down our 3, 6, 0, 0, 6, 12, 15, 30, whoa, fancy 30, 0. Yay! That's our remainder. Since we have our 0, we know that 3x, I don't want that there, it looks like a negative. 3x minus 6 is a factor of p to the x because the remainder is 0. All right, next. Factoring polynomials can be done in numerous ways. We know how to factor quadratics. And you do know how to factor quadratics. You've done it a lot. So if you can get your factors of your polynomial down to a quadratic, then you're good to go. I have to take a drink of coffee. Hold on a minute. It's 7 in the morning. I need a lot of coffee. Okay. If the degree of the polynomial is higher than 2, then we have other ways to factor. Remember, always look for a common monomial to factor first. Then try factoring by grouping. So always look for a common monomial, then try factoring by grouping. So here we are at example 2. Let's factor by grouping. So remember how to do this. You want to look at your first two terms and say, first of all, make sure it's in standard form, which means the exponent of your variable is decreasing, 3, 2, 1, 0. And now look for what they have in common. So b cubed and 8b squared, I can take a b squared out of both of those, and I'm left with b minus 8. And then these, what does 5b and 40 have in common? I can take a 5 out of both of those. So I'm going to go 5b minus 8. And then I'm happy because I have the exact same thing here as here. I'm going to put a plus sign there because I'm going to take out a positive 5. I put the plus sign in at the end because sometimes you're going to take out a negative because you need these. Oh my, what in the world? Hold on, guys, sorry. All right. You need these to be exactly the same. I'm not really sure what that is. So then maybe if I write over here, then we have b squared plus 5 times b minus 8. So, you can see I'm getting flustered here. I don't know what's going on. Why are you popping up at me? There's your b squared, there's your plus 5. I take b minus 8 out of both of those right there, and I'm left with b squared plus 5. Now, once you have factored by grouping, you want to look. This is still a quadratic, so you want to make sure that nothing can be factored out of that. Like, is it a difference of squares? It is a sum of cubes? There's different options. But in this case, we're done. Nothing else can be factored. Okay, so now we're at letter B. Remember, the first rule of factoring is to look for a common monomial to factor. So I can see that every term there, I can take out a 4r. So I'm going to do that. And so I have 4r times r cubed minus r squared minus 25r plus 25. So I took a 4r out. Now I can't just drop that 4r. But now I'm going to try to factor these by grouping. And these first two, I can take out an r squared. And I'm left with r minus 1. These next two, I can take out a 25. And I'm left with r. And here is where you're going to play around with the sign. Because I can see if I take a 25 out of that, I get a 1. But I need it to be exactly the same as this. So I need a minus 1. So what kind of 25 did I have to take out? I took out a negative 25. Because if I multiply that back in, I'll have my negative 25r plus 25. So this is the sign you want to be careful with, and you want to be sure these two are identical. So now, cleaning that up, I'm going to go right up here. I have 4r times both of these factors, this big one here and this big one here, have r minus 1. So I'm going to take out that r minus 1. And what am I left with? R squared minus 25. And then you look at that and you say, well, that's not done because this r squared minus 25 is the difference of squares. So then you'll say 4r times r minus 1, r plus 5, r minus 5. And that is fully factored. And remember, once that polynomial is fully factored, you know your zeros. That's really irritating. Okay, so just if this was an equation, what would the zeros be? 5, negative 5, 1, and 0. Don't forget about that right there. That's a 0. Okay, next, factoring the sum and difference of two cubes. This is another pattern you want to look for. I believe you've learned this before, but we were going to go over it. So the sum of two cubes is this. We have a cubed plus b cubed, the sum of two cubed numbers. That is going to factor to a plus b, a squared minus ab plus b squared. That is a factoring pattern that you want to memorize. Just like this one, remember, things are popping up everywhere. I don't have any idea how to get rid of that. Go away. Clear notifications. Go away. There you go. Okay. So we have a, here's your difference of squares. Remember that? That would be a minus b, a plus b. That's a factoring pattern right there. Here's another one. A cubed plus b cubed will factor this way. Example. Let's say we have x cubed plus 64, and you need to factor that. And, you know, it's kind of strange. And you think about it for a while, but you realize that 64 is really 4 cubed. So what you really have then is x cubed plus 4 cubed. And that is the sum of cubes. So then that is going to factor as x plus 4 times x squared minus 4x plus 16. And that's how you would use that factoring pattern. Next one, difference of 2 cubes. Very similar, but obviously it's a difference. And so that is going to factor as a minus b times a squared plus ab plus b squared. Another example, let's say we have 27 minus 8n cubed. If I want to factor that, 27 is really 3 cubed. 8n cubed is 2n cubed. So in this case, a is going to be 3 and b is going to be 2n. So applying this pattern, first I'm going to have a minus b. So that's 3 minus 2n. And then I'm going to have a squared. So 3 squared is 9. Then I need to do a times b, which is 6n, and then b squared, which is 4n squared. So these two patterns, the sum and the difference of cubes, you're going to use them and you need to know them. Here's a little pattern, because when you look at these, they're very similar, obviously. The only difference is the sign. The negative, when you're doing the difference, the minus is there, and when you're doing the sum, the minus is there. So a little pattern to remember this is, you have 3 signs in this. 1, 2, 3. So the first sign is the same as the problem. For example, if you're doing the sum of cubes, the first sign is positive. If you're doing the difference of cubes, the first sign is negative. The second sign is always different. So here I was doing the sum of cubes. The second sign, here is the sum of cubes. The second sign is negative. Here I'm doing the difference of cubes. The second sign is positive. And then the third sign is always positive. So right here is always positive. So if you can remember this for your signs, then all you really need to remember here is a squared, ab, b squared. That pattern doesn't change. A squared, ab, b squared. And you need to put in the correct signs using this pattern. Okay, so let's use this a little bit. We have example 3. 125 plus w to the 6. So 125 is going to be 5 cubed. And w to the 6 is going to be w squared cubed. If I do w squared cubed, I have w to the 6th. So both of these have to be cubed. So in this case, a is 5 and b is going to be w squared. It's the sum because we have a plus sign. And so writing that out, we have 5 plus w squared times a squared, which is 25. I multiply them together, and I get 5w squared. Put a minus sign in there. Remember, the second sign is different. And then the last sign is always positive, and that's w to the 4th. So all I did is I look at my problem, I figure out what are the numbers being cubed, and then I plug it into the form up here. Next one. I can see, remember your first rule is you always take out what's common, and they both have a 2 and a c squared. So I'm taking out my 2c squared. And then I'll see what I have left. I have c cubed minus 8. And that is the difference of cubes. So in this case, A, looking right here, I'm just looking at those A's and B's. A is going to be c, and B is going to be 2. And it's the difference of cubes. So what do I get? Well, don't forget that 2c squared you took out. And then you have c minus 2. And then you have c squared plus 2c plus 4. And it's factored. You need to know the sum and difference of cubes. All right, another way to factor is to use a graph to help find the zeros. If you know what the zeros are, then you can find the factors. So, example 4, use the graph, which is right here, of this polynomial provided, the graph is provided, to factor the function, verify all roots. So when I look at that graph, it looks like -1 is a 0. This is also a 0, but I'm not really sure what that is. It could be a half, or it could be some, tiny decimal off of a half. I don't know. But this looks like pretty solid -1. So I'm going to set up my synthetic division to -1, -8, -5. I'm going to put in my -1. The reason I'm doing that is if this is a 0, I should get a remainder 0 right here. This should be a 0. So let's see. I bring down my 2, multiply, -2, add -3, multiply 3, add -5, multiply +5, and there it is. I have a remainder 0. Therefore, -1 is a 0. So if -1 is a 0, then x plus 1 is a factor. Now, remember, we are trying to factor here, so I'm not so interested in my zeros. I'm interested in my factors. That is a factor. And when I divide this polynomial by x plus 1, which is what I did right here, I took those coefficients from this polynomial, I put -1 here, I divided. What do I have left? I have this polynomial left. And my degree went down 1. So therefore, when I do x plus 1, which is the 0 from right here, times, here it is, this was an x cubed polynomial, x cubed, so now I'm at x squared. So I have 2x squared minus 3x minus 5. And I have factored 1 0, or 1 factor, out of my polynomial. If I would multiply these two polynomials, or these two, these are two polynomials together, I would get this. So I'm trying to factor it. So I've taken out my first factor, x plus 1. I'm now left with this. And this is going to also be able to be factored or used to find the other zeros. But since it's a quadratic, let's just try to factor it. Because remember, over here on the graph, we know there's another 0, isn't there? So what do we have if we factor this? We have 2x minus 5 times x plus 1. That is how this quadratic factors. And then don't forget I have this x plus 1. So the factored form, look at that. I have 2x plus 1s. And then I have 2x minus 5. That is how we would write the factored form of this polynomial. So we use a graph, we find a 0. We divide in the 0 using synthetic division to verify it's really a 0. You have to do that. You've got to verify what you think are the zeros. You get the remainder 0. That says, yes, it is a 0. So then you know that x plus 1 is a factor. So you write it, x plus 1 times what is left here, which is a quadratic. And since it's a quadratic, you factor your quadratic. Once you factor your quadratic, you have your 3 factors, and then you rewrite it in a nice, neat form because you have 2x plus 1s. Incidentally, look over here. When you see the graph bounce at a 0, it comes up and it bounces and goes down, you know that there's 2 of those zeros. There it is, x plus 1 squared. Oh, right it is. What do you notice about the factored form of the polynomial? Why did it happen? So I just said it. There are 2 zeros at -1. This is called a double root. There is a curve at the graph that touches at 1, but it does not cross. So this graph, it comes up, it touches at -1, and then it goes back down. The graph bounces at -1. It doesn't cross the graph, it bounces. So it is we're going to talk about that more, so make sure you pay attention to that. Anytime you bounce on a graph at a 0, that means it's at least a double root. It could be more. All right, moving on, example 5. The population of an endangered species of bird in the years since 1990 can be modeled by the function of P of x. Identify the year that the bird will become extinct if the model is accurate and no protective measures are taken. Use the graph to factor P of x. Okay, so we are looking for when the bird will become extinct. So if it is extinct, that means there are 0 birds left, right? This is number of birds. This is years. Maybe it's kind of right. I don't know. Years. Okay. So if it's extinct, that means it's a 0. That's what it's saying. What is the 0? Does that make sense? So we are going to, it looks like the 0 is at 24, but we are going to verify that. And so the way I verify that is I set up my synthetic division, and I have -1, 32, -2, 24, 7, 68. Those are all my coefficients right there. And then I divide in. I believe 24 is my 0. So I'm putting that there. And I am going to bring down my -1, multiply, and I get -24, which gives me 8. Multiply, and I get 192. Add those together, and I have -32. Multiply again, and I have -768. Add in 0, so there it is. The remainder is 0. Therefore, what does that tell me? That tells me that 24 is a 0, and that x minus 24 is a factor of the polynomial. And 24 is a 0. All these things mean the same. This is the same as that. They mean the same thing. So it says identify the year that the bird will become extinct. So it will become extinct in 24 years. Well, when did we start this? We started this in 1990. So we're going to say, all right, if we start in 1990 and then 24 years later we're extinct, that's 2014. So in other words, this bird is already gone. Okay. I think that's it.